Hi guys, today we'll be talking about RDBMS. So what is RDBMS? The RDBMS is a short form or an acronym for Relational Database Management System. So let's analyze each word individually. Relational, it means that the data are related to each other in one way or the other. Database is the actual storage or the physical hardware in which data is being stored. You can visualize it that way. And management system, just think of it like a system, like a computer. So in this picture, if you see, there are like different buckets, and in each bucket there are tables, and each table has got its own data. So all these tables are there. They may be related to each other. So like table one, A1 is related to A2, or A1 is related to B1, and so on and so forth. So these are the relationship is there. That is why it is called relational. And databases, these three buckets, or you can call each bucket as a database also. And there's a server which actually coordinates the data transfer between these. So that is the management system. So why is it important? Because of this kind of an arrangement, it is easy for us to understand the data, to visualize it, easy for us to access it, and also make operations like update operations, insert operations, delete operations, read operations, and all. And it is very easy to maintain as well. So we'll go in this video. We'll talk about how a data could be stored and what are the different pros and cons of the ways of storing it. So that would actually lead us uh, to prove this point. That is how RDBMS is easy to maintain. So let's begin with a simple example. Assume that you are the owner of a supermarket, and in the supermarket, you are selling things like groceries, fashion, stationery, etc. And you are maintaining a register where you list down all the items that you have in your shop that are ready to be sold. So let's think of it like this. So this is the register or the table that you have, and this table is stored here. So in this, you have got the product IDs and the product names. So just this like a serial number. So you've got wheat flour, you got milk, which fall in the category called groceries, and then you've got notebooks and pens, which fall in this category called stationery, and then you've got belts and hats, and they fall into the category of fashion. So this is pretty simple to see, right? Now let's add more use cases on top of it and see how the storage of this data progresses, and how is it important to have, and why is it important to have a relational database. So let's add some additional information. Now that if you look at this, here you have the items listed, but you don't know the price of the items. Since you are selling them, you need to add the prices. So how do you add the prices? It's pretty simple. You add a column. So now let's add some more information, like assume that you're selling one of the stuff. So this table talks about what you have and you are ready to sell. But this table does not tell you anything about the items that have been sold. Things like whom you sold it to, when you sold it to, at what price you sold, and what was the item. So how do you store that information here? Uh, Again, if you go by the earlier approach, we can simply add a column to the right, and then we tell that okay, this item has been sold. So let's see. I added a column called sale information, and then I told that I've added the information called sold to John Doe at the rate of 145 on the 15th of July. Uh, so this solves the purpose, but it has its own intricacies and drawbacks, which we'll be discussing in the later slides. Now, the first sale was fine. Now what if you made a second sale of belts? Because in case you own a supermarket and you're selling belts, that doesn't mean that you're selling only one belt, or that doesn't mean that one customer has come and purchased all the belts from you. No. So a customer would come, and and that customer would probably buy one or two belts from the hundreds of belts that you have in your store. So now there would be a second sale in this case. So if we add the second cell, where do we add this additional information? Say the last time John Doe came and made a purchase at 145, but this time John D has come and he's purchasing at 130 on the 16th of July. That's the next day. Then where do you store this information? Do you add a new column on the right? That could be again like a solution. Or do you replace the information? That is, you remove this information and then replace it by sold to John D at the rate 130. on the 16th of July? Or do you keep both the information, like in the same cell? You say that's information number one, John Doe, and information two is John D. So how does it work in that case? Uh, so in this case, what are the intricacies and what are the benefits and drawbacks of each case? Let's talk about that. So let's add a new column. So of course, you have added the information of the first one and the second one. So tomorrow, if somebody asks that how many belts did you sold and who are the customers that you sold them to, you can simply fetch this information and that information, and then you can show that. But the question is, you have got hundreds of belts. How do you add that? You keep on adding that many hundred of fields or the columns in this table. You keep on adding a table and then keep on updating the record next to it. Now, the next thing is, the moment I add a table, here you see for notebooks or pens, there is not even one cell, but I still have a memory allocated to that particular notebook or to that particular item. Then this space is gone wasted. So in a physical notebook or a register where you're storing all these tables, you cannot keep adding the columns, isn't it? So because of these two cases, is it sustainable? Definitely, it's not, because say today you have 100 belts on sale, and belts are on high demand in your locality, and all the 100 got sold in like a week's time. So tomorrow you would be purchasing another 500 belts, right? How do you store this 500 information, and do you keep on adding columns for each sale that is being occurring? Definitely no. Now let's check out the second option that we discussed is we replace the last information. So we'll replace this information with the latest one. What would happen in that case? On 15th, John Doe purchased. On 16th, John D purchased. On 17th, say John Doe came and purchased again. And on the 18th, some other person came and purchased. So if I keep on replacing the information in this cell, what would happen is that in the end of July, if somebody comes and asks me what was the sale that John Doe did on the 15th of July, my that information is no longer there in my table, so I won't be able to fetch it and show. These are especially important for reporting purposes. So also, second thing is that how do I find, say in the end of July, somebody comes and asks me that what is the total sale that has been done in the month of July? I don't have that information anymore because I have been replacing the existing information with the latest one. So that also is not a viable approach. Let's see. The third approach is that we keep both the information in the same cell in this format, like sold to John Doe at 1:45 on the 15th of July 2020, and second entry sold to John D at the rate 1:30 on the 16th of July 2020. Uh, what will be the drawbacks of this case? Is that if somebody asks me, give me the total discount that has been given on belts. How do I find that? Because in the same cell, I have information for 145, I have information for 130, I have information for God knows whatever amount, like 150 also, or maybe 138 also. I don't know, right? So what would happen is that I would fetch all the belts information, then I'll have to go line by line in this cell, whatever information is there. I have to decode it. I have to convert that sentence into and then figure out what the value it was sold at. Now the next question happens here is that while at a time of entry, say I have a standard of entering that sold to John D at 1:45 on the 15th of July 2020. Tomorrow my assistant comes in or my partner comes in and he enters that belt sold at 1:45 on 15/7/2020 to John Doe. Then this logic that I'd be applying to figure out what the total discount value is would go for a toss. I won't be able to have a standard logic to calculate it. Then I have to do all the manual processes. So in all these cases, this entire thing fails. What's the alternate that we have? The alternate is that we add another table, and in that table we mention only the sale information, nothing else. Here, in this table I'll have something called a sale ID. I'll have product name, customer name, selling price, listed price, date. So if you look at it, if somebody tells me at the end of the month, tell me how many belts have been sold, I can simply see the call product name called belts, and then I count them. What is the total price it was sold? I'll simply add the sub selling price, and then show it. What's the total discount that have been given? Then listed price minus selling price, and I'll aggregate them for the belt. In the month of July, I'll select only the ones where the date is in July. So this solves a lot of purposes for me. Uh, like here, so these aggregations is solved. Information replacement, that is also solved. Okay. Now the next question is that how many columns do I need to add? Okay. The thing is, I don't have to add any further columns. I just simply insert another row. If tomorrow some say John Doe comes again and purchases a belt again, then I'll just simply add another row here, like three belt John Doe sold at say 145 again, 150, and then date of sale would be 17th. So that's how it progresses. Now, this is what the approach review is. Like, can I find the past sales? Yes, I can. Can I find the item sold at a discount? Yes, I can. Do I need to add any additional columns for every new cell? No. Just insert a row in the second table with the new cell information. Am I creating unnecessary cells where no value will ever be inserted? Definitely no, because if a pen is not sold, I will not make an entry here. If a notebook is not sold, I'll not make an entry here. So the empty cells that were there in the earlier slides, like this empty cell, these empty cells, these are all gone, right? That requirement is gone. So I'm saving on space. Then can I get aggregated report like monthly purchase or customized purchase and so on? Yes, definitely. That's how we explained. Now, everything is perfectly fine in this case. So, what's wrong in this approach? In this approach, what would happen is, say, I have a standard of entering belt, 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 but here I've written belts, right? So, if somebody tells, and if I don't have the listed price, somebody tells me that, okay, ask me to tell the listed price of belts. I'll search for belts here, I'll not find because this is named as belt. That is one issue. Second issue is that I am entering belt. My assistant enters belts. Then again, or he enters a wrong spelling for belts. Then what would happen? I cannot make an aggregate because the computer will not understand the variations in the spelling. So I have to tell the computer about, okay, these are the different variations. That is another way of handling it, but that is not a good way of handling, right? The third thing is that what if two people with the same name they come in, say John Doe has come on the 15th, and then another John Doe, not the same John Doe, has come on the 17th. Now if somebody asks me to tell that at what price did John Doe purchase, I'll just simply aggregate both the John Does and show it. And then the auditor would ask me that, okay, tell me which one for this John Doe and which one for the second John Doe. No, I won't be able to find that out. So these issues they do come up, and apart from that, there are some additional issues also. But these are the glaring ones that stare at your face. So these are definitely a no-no. So we have to make another arrangement for this. So in that case, what do? We put another table, and what we do here is, if you see here, we had product name and customer name. We instead of making it as customer name, we make it as customer ID, such that if it is 5, that means it is belt no matter what. So I'll just put 5 5. So the spelling error is eliminated. Similarly, for customer name, I'll put another table called and then replace it to customer ID. So in this table, I'll write customer ID 1, 2, and then I'll fill their contact details if needed. And here, if you see, even though there were two John Does with customer ID 1 and 3. So if I see that first customer has customer ID 1, second customer has customer ID 3. So this way, if somebody asks me, okay, tell me what is the total sale made to John Doe in the month of July, then I would of course ask that, yeah, I can give you that, but tell me which John Doe. I see two John Does in our account. Then the person says, okay, fine, give me the details of second John Doe. And then this customer ID 3, I'll search over here. So for customer ID 3, what is the total sale? And then I can easily figure it out. So if you see here, this table has got this product ID and customer ID, and the product ID is repeating. But in this table, product ID is not repeating. What does that mean? This means that the first sale was made where a belt was sold. Second sale, also a belt was sold. But in first sale, it was sold to customer ID 1. and in the second sale it was sold to customer ID 2. So this tells me that okay, first sale a belt was sold to John Doe, second sale a belt was sold to John D, and so on and so forth. So this solves a lot of problems. Now let's look at the some uh, some key information here which we already discussed. In this table, if you see, every row has got a unique identifier, right? Wheat flour identifier is one, milk identifier is two, and so on. So if ask you what is the product whose product ID is 5, you simply go ahead and check it out here and then tell 5, that is belts. I ask you who is the customer whose customer ID is 1. You simply come ahead here and then say John Doe. Similarly, if there's a customer, another customer with the same name as John Doe, then his customer ID will be 2. So I'll ask you that who's the customer ID 2? Then you again come ahead here and then say that is again John Doe. So what if I ask you, okay, tell me the customers whose names are John Doe? Then you can simply figure it, search it on this, and then say that on John Doe with the name John Doe, there are like two customers, that is customer ID 1 and customer ID 2. Uh, so if you look at it, so each customer in this table has got an unique identifier, which is a customer ID. Each product in this table has got a unique identifier, which is called a product ID. Similarly, each cell in this table has got a unique identifier, and that is called the sales ID. Okay. And if you look at it, this table, that sales table, is referencing to the product ID from the products table and also customer ID from the customers table. Okay. So what are the benefits here that you are seeing? That it takes care of the items with the same name. It takes care of unnecessary repetition of data, and it is very useful for aggregation. And say tomorrow I have made an error. I say that okay, the spelling of pen should be changed to pens, or say belts should be changed to belt. I don't have to change it every time here. If you look at it in the earlier case, here I don't have to change the records in this row, and so on. What I can do here in this case is that I can simply change the spelling here, and it takes care. So this is extremely easy. So first thing, let's talk about some jargons. First thing is that each data, what do you call storage, is called a table. A table has got columns and it has got rows. In case of database, we call each column as a field. So this is a table. This matrix is a table. This is each column is a field, and each row is also called a row, as it's the same thing. Database is all these together, and relations is what we'll discuss once we talk about primary keys. If you remember in the last slide, we talked about that each item in a table has got a unique identifier, and this identifier does not repeat it. In this case, if you see, it is 1 2 3 4 5 6. So like notebook and pen cannot have the unique identifier as 3 each. Notebook has the unique identifier as 3, pen has it as 4. So pen cannot have it as 3. So this is like unique for each row. So when a column is unique, it is called a primary key. There could be multiple unique columns, but we always choose only one column which has unique value. If you look at this here, these values are unique, like 20, 25, 50, 15, 150, 600. These are unique, but doesn't mean that these are primary, because there could be another item which has the same price as wheat flour. There could be, or we can have restrictions that okay, this is unique no matter what, but there's one unique identifier which we says that okay, this is unique for this row, and we call this as the identifier for that row. So this is called a primary key. Now in this case, in this table, if you see, there is a field which references to the unique identifier of another field. Like this product ID is referencing to the unique identifier of this table. Similarly, customer ID here is referencing to the unique identifier of the customer's table. So these fields are called foreign keys. So foreign keys, they can have the values repeating like 5 and 5. So in a foreign key case, the values can repeat over the rows, but they reference to a primary key of some other table. When it comes to a primary key, this a primary key in a table is the field that uniquely identifies each rows, and this data does not repeat within that particular table. So this is what you call, this reference is what you call relations. So relational database management system. So with that, the basic fundamental concept of a RDBMS is over. Thank you.